Hello, welcome back. What's the best way to watch a fishing show? Live stream. All right. So we have got a almost like our last video in terms of trig. Uh, it's basically problems with general triangles. Okay, now what this topic really means is we're not going to tell you its sine rule. We're not going to tell you its cosine rule. We're not going to say area of a triangle using this formula or that formula. We're just going to give you a general triangle problem, and then you're going to have to decipher and figure out which way you or which formula you might need to use, how you go about solving it. That's on you. Okay, so I'm going to give you a little bit of an overview and we're going to tackle one question together for the sake of time. If you're in my class at school, we'll see a couple more. But just to kind of break down how I would almost figure out what to do with any general triangle problem. Okay, so let's remember a couple things. Okay, if you are working with any right angled triangle, your options are it's Sokotoa or you're using the Pythagoras theorem. Okay, those are your two options. If you see a right angled triangle, I want you to figure out, can I use Sokotoa? Can I use Pythagoras theorem? That's your helpful start. For all your other triangles, where you have non-right angled trig, it's either going to be sine rule, cosine rule, or area of a triangle. Okay, now hopefully we remember sine rule is a little bit of some sort of crisscross fashion. If I've got, oh, yuck. I'm working here. I'm working on it. Say, for example, you've got A. I should probably make it capital A, capital B, and then, A, B, A, B. That's what sine rule is going to look like. Cosine rule is when you're going to have something that looks a little bit like, maybe something like this. You'll have C, you'll have B here. You know what? Doesn't really matter. I'm going to go with this triangle. And for this one here, it's when you kind of have two sides, the included angle and the opposite. So I'm going to have some sort of arrow. And for the area of a triangle, all you really need is your two sides and your included angle. Okay. So this is how I try to visually figure out, okay, what am I working with? That's how I try to figure it out. Okay, let's try hit this question here. So we're saying here that a ship sails 40 kilometers on a bearing of 32 degrees true, and then sails 14 kilometers due east. Find the current straight line distance from the starting point. So any triangle question where they don't give you a diagram, draw the diagram. Don't be lazy. Draw it nice and large. Okay. So let's say we're starting this guy. Let's give him a starting point. He's going to start there. Now he sails 40 kilometers on a bearing of 32. So I'm just going to draw a line here. I'm going to say that that's, north was there, 32 degrees was there, and he did this for 40 kilometers. Okay. Now what's happened here is once he's hit that point, 40 kilometers, it says here that he sails 14 kilometers due east. Hopefully we remember that if that's north up there, east is actually that way. So I'm going to go 14 kilometers this way and label that there. Okay. Now what happens here is we're trying to find the current straight line distance from the starting point. So in other words, I'm trying to find that length there. Okay. So first of all, I take a look at this triangle. Am I working with a right angled triangle? Let me draw it maybe a slightly larger here so you can kind of see what's going on. And this is a great technique here, by the way. When your diagram is drawn a little bit too small, draw it out separate so you can actually just draw one triangle, deal with one triangle at a time. Okay, all I know is that that's 40 and I know that that's 14. And I'm trying to find the length, the distance, that x. Okay, now I need to know a couple of things. Are there any angles that I know? Well, first of all, it's not really possible for me to know that angle quite yet, but I should be able to figure out something about this giant angle here. So I know for a fact that if that's 32 there, I can see that that is 90 degrees there. Hopefully you can see that. And all I got to find is that little angle in there. Now I can see that that would be 32 because it's alternate with that one there. So that would be 32. Now doing the math there, that means this total angle here is 122 degrees, 32 plus 90. Okay, now at this point here, I can almost read exactly what my question wants. I've got two sides. I've got an included angle, and I'm trying to find the opposite sides. I'm working with a cosine question. So here, I would go looking for a side as well. So I'm going to note that it's going to be the x squared formula. Let me write down the whole cosine rule. So c squared equals to a squared plus b squared minus 2ab sine c. I got there. Okay, so let's see. We've got x squared equals 2. A and b are going to be 40 and 14. All right, same thing. A and b is going to be 40 and 14. And then my sine c is going to be sine. Oh, sorry, not sine. Guys, did anyone pick that up? This is what rule? It's the cosine rule. So that means this should now be cos c, cos 122. Okay, now while we're here, let's square root that big boy. And x would be square root. See if you can beat me to it. You're probably already there because you guys are all smart. Plus 14 squared minus 2 times 40 times 14 times cos 122. Those brackets. X here would be something like 48.88. Now, because we are finding a distance, I don't need degrees, I don't need anything. It's just going to be that bad boy. And we're assuming kilometers because all of our things have been in kilometers. Good timing. I think my wife is home. So hope that makes sense. Enjoy, and I'll see you guys later. Bye.